Alright, so welcome back to our last video for lecture 5. So I'm going to end lecture 5 with a sort of demo that is related to a simple game called rock, paper, scissors game. So we're going to try to implement this game. We're just going to do the very basic part, which is we were going to get the choices from the two players, and then we decide who wins for that particular round. So here is the description of the problem that we try to solve. So we try to write a simple rock paper scissors game, and that's played by two players. It will accept the player's choice. So the player will actually enter either rock, paper, or scissors, and then it will output the outcome of the game, a win and a draw. Okay? The outcome of the game is basically win or draw, right? So here are the sample runs. The sample runs basically would be like this. So assuming that we are putting the code in the rps.py, so you can see here that the inputs are, let's say the first player enters scissors, the second player enters paper, then who wins? In this case, the scissors wins, right? Scissors wins paper. So in case you forget, the rule is like this. So rock is actually overpowered, or maybe I should write like this: rock actually dominates scissors, and eventually scissors dominates. Okay, so you understand that this is D is dominate, so I'm just going to put D here. So scissors dominates the paper, right? Because scissors can cut papers, and paper eventually dominates rock. So there is a triangle relationship here. So here in this case, we can see that in the sample run 1, because a scissor dominates the paper, so therefore player 1 wins. This is the output after we check out the inputs given by user. And in the second run, scissors, if the first player chooses scissors while the second player chooses rock, so actually rock dominates scissors, hence player 2 wins. In a situation where they entered two similar choices, such as paper and paper, that will actually give us a draw. So that is actually the requirement of this program, and let's see how we can actually develop this program, right? A simple game. So now here is a file that I prepared, and we're going to write the codes for that. So I'm going to name this properly as rps.py. Right. So here's how we will do it. So first of all, we need to get the player's input. So the player's input is either rock, paper, or scissors, right? So then I can store it as P1. P1 is actually just get the input, and then I say player 1, right? So the player 1 is going to enter its input, and that is a prompt. So because this is a string, we don't actually need to do any conversion, just leave it as it is. Then after that, we have the second player, right? The second player, and hence the prompt is for player 2. So what do we do next here is we're going to determine the outcome of the game. So how do we determine outcome of game? Well, there's just a lot of possibilities, isn't it? Right? So here what we have is first of all, let's check what is we have to check for every possibilities, and then we decide the outcome. So what's the one of the possibilities? First of all, we handle the situation where the player actually enters rock. Okay, if he enters rock, so what would be the winning condition, what would be the losing condition, and what would be the draw condition? So let's do the draw first, because draw is easiest. So the drawing condition is if, right? So now here you can see this is a nested if statement. if the player is equals to rock, player 1 is equals to rock, and then player 2 is equals to let's say rock as well, then obviously it is a draw, right? It's a draw. So then you can just write something like this is actually a draw, so you can just print draw, right? Print draw. Or if you prefer, you can just write to make life easier to make life easy. Why not? We can do it like this. Since you see that we are always going to compare whether P1 and P2 is the same or not when it's draw, why not we just do it like this? So let's just do the draw case first for everyone. So I can write something like this: if the P1 is equals to P2, right? Then what I need to do is I'm sure that it's a draw. So I can say that this is a draw, right? So I can say print a draw, right? Now else, if let's say none of this is correct, okay, if this is not the same, then what I want to do? So what I want to do is that I want to say that I want to check whether it's a winning case or whether it's a losing case, right? So in this case, you can do something like this. Else if P1 is equals to rock, okay, rock. So what is the case where the player 1 wins? Okay, this one is the case where player 1 wins. Okay, let's just combine them, right? Just to make it shorter. So if player one is rock, but then the player 2 is equal to, so rock actually will dominate Caesars, right? So Caesars. So if player 2 is Caesars, then we are sure that it's winning. What is the other condition that we want to check for the case the where the player 1 is winning? So the other situation is where the player 1 actually is a paper. So it's a paper, and the player 2 is, okay, when the paper dominates what? Paper dominates rock, right? So when the player 2 is rock, then we know that we are winning. Or another case is where the player 1 is equals to Caesars, and then the player 2 is equals to paper. Then we are sure that we are sure that these are all the possible winning cases for player 1, right? Player 1 wins, right? So then here we can just write print player 1 wins, right? So there are only 3 cases. It's either it's rock. If it's rock, then the winning case where player 2 seizes. Or another case is if either one of these happens, right? Which is when the player 1 is paper, then the player 2 is rock, then this is also the case where player wins. Or in the case where player 1 is scissors and then player 2 is a paper. So if either one of these happens, then we know that it's actually a case where player 1 wins. To determine where the player 2 wins, well, that's actually quite easy, right? All we have to do is we just change all the P1s to P2s and P2s to P1, then that actually will corresponds to the winning case for player 2, right? Because we already have the winning condition for the for the for the win case, right? So therefore this one will be player 2, right? So there you have it. That should be all for the for this rock paper scissors games. Let's give it a try. All right. So now I'm just gonna try to write the program, and then we're going to test it out. So let's try and run this. So then let's try a rock versus rock. It's a draw. Run again with paper, and it's a draw. So and then we have scissors, right? Scissors, and then after that we have so we have tested all the 3 cases for draw. Now let's try the cases where the player wins. So let's say if I try player is rock, so rock actually dominates a scissors, so therefore player one wins. We'll run again with player one being the paper, so paper dominates rock, right? So player one wins again. Now if I try scissors, and then scissors will dominate paper, and player one wins again. Now let's try the case where player two wins. So suppose let's say player one is rock, then what dominates rock? Well, the paper dominates rock. So when the player two is paper, it wins. So if let's say player one is a paper, what dominates a paper is actually a scissors. So now you can see player two wins. If you were to run this again with what you call with the scissors, and then so what will dominate scissors? That will be the rock, right? So if player two is rock, then it wins, right? So what we haven't actually checked really is if let's say the user type strings that are invalid, right? Let's say you type something like Spider-Man or whatever that is not rock, scissors, or paper, then we need to check for invalid cases. So how do we do that? So for that, I will leave that as an exercise for you to try. In fact, it's actually quite easy now, given that this is how we write the code. So just figure out how we can, add our own code to handle the invalid cases. I'll leave this to exercise for you, and hopefully, once you get it done, you can see that it's working fine in your program. So that concludes the lecture for lecture 5. So I hope all these examples will help you understand very well what is if statement and how we use that to represent the selection control structures. All right. So I'll see you guys next week. Bye bye.